So the same question again, the effective nuclear charge experienced by valence electrons decreases across a period is equal to the total number of protons increases across the period or remains constant across a period. What is the ZEF? What is the effective nuclear charge? The answer is that they increase across the period. But why is that? The effective nuclear charge is equal to the attraction by the protons, the nuclear charge, minus the shielding effect. When you go across the period, the shielding is the same. The protons increase by 1 per element, but the shielding is the same because you are still in the same period. The same level, same energy level means constant automatically. The shielding, electrons added to the same shell don't shield each other effectively. Therefore, ZEF or the effective nuclear charge increases because you are increasing the nuclear charge, but the shielding is almost the same. That's why the atomic radius decreases, because the attraction is more, causing the outer electrons to be attracted. So if the outer electrons are attracted more, then this means that the size becomes smaller. So memorize this. ZEF is equal to Z protons minus shielding. Increases left to right across the period, stays constant down a group. Example period 2, lithium, ZEF is 1.3, beryllium is 2.4, carbon is 3.1, oxygen 4.5, neon is 5.8. So the higher ZEF means stronger pull on the valency electrons. Which pair of elements would you expect to have the most similar chemical properties? Sodium, magnesium, sodium, potassium, chlorine and argon, oxygen and fluorine. Of course, it's sodium and potassium. They are in the same group. Elements in the same group have similar chemical properties because they have the same number of valence electrons. Sodium and potassium are both in group 1 with valency 1 valence electrons. They both form +1 ions. They react vigorously with water and form similar compounds like ionic compounds. So the sodium and magnesium are in different group. Chlorine and argon are in different group. Oxygen and fluorine are in different groups. They can never have the same chemical properties. Only elements with the same valence electrons have the same chemical properties. So memorize this. Similar properties equal to same group. Same group equal to same valence electrons. Same valence electron equal to similar reactivity. Group 1 alkali, lithium, sodium, potassium, rubidium, cesium, francium, all form +1 ions react with water. Group 17, halogens, FClBr, astatine, they all form -1 ions. Group 18, they all unreactive, right? This is a proof. Which of the following has the smallest ionic radius? Oxygen 2-, fluorine-, sodium plus, magnesium 2+. There is something very nice about all these elements, that they have O2 8 electrons. 2- means it has added 2 electrons, so it becomes 10. Fluorine minus is 9, adds 1 electron, become 10. Sodium plus is 11 electrons, loses 1, become 10. Magnesium 10 electrons because 12 has lost 2 electrons. Now they all have 10 electrons but different number of protons. Which one will have the smallest radius? Your answer? Mr. Magnesium 2+. Why is that? They all have the same electrons, so they are isoelectronic. Isoelectronic means the same number of electrons. For isoelectronic species, the one with more protons is smaller because the same number of electrons is pulled by stronger nuclear charge. Protons, O2-, F, Na+, magnesium 2+, they all have the same number of electrons, but magnesium has the most protons. When you have most protons, the attraction to the inside is more, makes the size smaller. That's why the rest is big, but this one only is the smallest. So remember, isoelectronic species, same number of electrons, different number of protons. More protons equal to smaller radius. So 10 electron series, smallest to largest, aluminum, magnesium, sodium, until nitrogen is the biggest. Why is that? Because they all have the same number of electrons, but nitrogen has the highest number of protons. No, the biggest number of protons will be aluminum. That's why the size is the smallest because of the attraction. The smallest number of protons is nitrogen. That's why it has the biggest size. So this is the largest size. Protons pull electrons in, so smaller ion. Very, very important trends a must-come question in the exam. The second ionization energy of sodium is much higher than its first ionization energy. Why is that? We said, is it because the electron is in higher energy level, or the second electron comes from a stable noble gas, or sodium has lower electronegativity, or the atomic radius increases? Which is your answer? I'll give you a chance to think. What is the answer? Why is the second ionization energy of sodium is much higher than the first ionization energy? Why it's more difficult to remove the second electron than the first electron? Because the second electron comes from a stable noble gas configuration. Let's see. What is sodium? Sodium is 281. When you remove the first electron, it's something fun. It's nice because it makes you a stable, higher stability because the last shell here is stable. It has 8 electrons. But if you try to remove one more electron from 28 into 27, you are changing something stable ion into something unstable. So that doesn't add anything. It's not recommended. That's why it's difficult to remove this electron. So it's better to keep it. That's why the second ionization energy is much bigger than the first ionization energy. More explanation is to say like that. The sodium has electron configuration of 281. The first electron removed is the lone 3s electron, easy to remove. After losing it, the sodium has the stable configuration of Ne. The neon is 28. Removing the second electron means breaking into this stable noble gas core, which requires much more energy, about 10 times more. Successive ionization energies, each successive ionization energy is higher than the last. Huge jump happens when removing core electrons. Here I removed an outer electron which is not core, a valency. What if I have magnesium, 282? If you removed 1 and 2 electrons from here, it's okay. If you remove the third electron, you are removing electron from a core. So this causes the jump to be big. So ionization energy number 1 is 496, but 4562 when you remove the second electron. Huge jump. The jump reveals the number of valency electrons. So sodium, big jump after the first ionization energy, so it's in group 1, 1 valence electron. Magnesium, big jump after the second ionization energy, means it is 2 valence electrons. This is very, very important. You may be asked to find the group number or the number of valence electrons by seeing only the numbers of ionization and seeing where is the biggest jump. The next question, which property would be the highest for cesium? Ionization energy, electron negativity, atomic radius, or electron affinity? Yes, atomic radius. As you go down, this is at the bottom of the group, excluding the radioactive fraction. Going down, group atomic radius increases. Being in period 6 with 6 electron shells, it has one of the largest atomic radii of all elements. Its ionization energy and electron negativity are very low. Don't say that, they become high. Why? Because it's very difficult or very easy to remove the electron. Very easy. Can you see where is the electron? Cesium is here, and you have many layers of electrons. Electron is very far, and it's also shielded too much from the nucleus. So you can't say the ionization energy is high. It's very small, and you cannot say the radius is big. So the radius is big, but you cannot say, the electronegativity is big. Okay, electron affinity is also low. It's very difficult to add an electron to this one. Memorize this, the cesium, the extreme metal, position in group 6, group 1, period 6. Valency 1 electron, the 6s. Atomic radius is very large, 265. Ionization energy is very low, and electronegativity is very low. Metallic character is very high. It's very easy to lose the electron. Cesium plus water gives explosion. It is a very reactive metal. Question number 14, we are almost done. We have just 15 questions. Which of the following correctly lists elements in the order of increasing first ionization energy? We said ionization energy increases. How does the ionization energy increase? For ionization energy increases, let me give you a chance to answer first. 5 seconds. Don't forget, in the exam, you must answer. You must give an answer. Is it this one, this one, this one, this one? What is the answer? The correct answer is potassium, sodium, lithium. They are all in group 1, right? But potassium at the top or potassium at the bottom. As you go down the ionization energy, yes, it decreases, it becomes easier. So potassium is the smallest, while lithium is the highest. The electron is close to the nucleus. It's very difficult to remove in lithium. The O in group 1 going down a group ionization energy decreases. Easier to remove the outer electron due to the large radius and more shielding. So the potassium has lowest ionization energy than sodium, then lithium. Highest ionization energy, increasing order KNALI. Memorize this. Lithium, highest and smallest atom, and cesium has the lowest ionization energy and the largest atom. The trend is ionization energy decreases going down. Reason outer electron further than from the nucleus. Memory trick, smaller atom, tighter grip, higher ionization energy. The last question, compared to neutral chlorine, a chloride ion has more protons and larger radius, same protons and smaller radius, fewer electrons and larger radius, same protons and larger radius. The answer is same protons and larger radius. When chlorine gains an electron to become Cl minus, what happens? The protons stays the same, 17. Nuclear reaction does not occur in the chemistry.